So this video covers two pretty important things in trig. So we're going to build up the Pythagorean and the quotient identities in trig. So we'll just jump right into it and talk about the first Pythagorean identity. So I think it's very helpful to know why these work and that it's not just some, made up math fact. So if you've been following along with my videos, so I have been talking a lot about working with standard position. So we have this angle theta that we create from the initial side and the terminal side. We choose a point on the terminal side, and then we can label the sides x and y. We can find the lengths of these while also respecting whether they're positive or negative. And then we also want to find this side r, and you'll notice this is just a right triangle, so we talked about this a whole bunch. So we x squared plus y squared equals r squared. So what I want to do now is I want to take this result and I want to analyze this a little bit farther. We're going to play around with it a little bit and see what we get. Okay, so I got x squared plus y squared equals r squared. So what I'm going to do is I'm just going to divide all sides by r squared and see what happens. Okay, so if I do that, I can just rewrite this as x over r and then square that, y over r, square that, and then r squared by itself. That'll just be 1. Okay, so now what I want to do is I want to think about the 6 trig functions that we've been building up. So remember, cosine is x over r and sine is y over r. And so if I go back to this, then I have that this x over r can actually be written as cosine theta. And then this y over r, like we just said, this can be rewritten as sine of theta. So I just made this like very tiny little adjustment to this equation, and I've gotten the trig functions kind of out of this, and we get our first Pythagorean identity: sine squared theta plus cosine squared theta equals 1. And just notice I did flip the order of these. This is just the order that we tend to write this in. So just keep that in mind. Okay, so using similar logic, we can derive 2 other identities. So let's go back to that same equation. So now what I'm going to do, I've got x squared y squared equals r squared. I'm going to divide all sides by x squared, and let's just see, what do I get? So if I divide, I get 1 plus y over x squared equals r over x squared. Okay, so we've got y over x and r over x. So if I come back to my handy dandy list here, y over x and r over x, those correspond to tangent and secant. So what I can do now, let's see, go back to this. I can actually identify this then as tangent, right? And this other one as secant. And so the next Pythagorean identity is tangent squared plus 1 equals secant squared. Again, I flipped the order of this. This tends to be the way that you see this identity. And then for the last one, so now I've got x squared plus y squared equals r squared. So now let's just divide by the one variable we haven't divided by yet, so let's divide by y. And so in this case, I'll get x over y plus 1 equals r over y squared. So this might be a good time for you to pause and see if you can come up with the identity on your own. So I'll even give you, if you're not sure, here's the little cheat sheet so you can hit play when you're ready. Okay, so I can see from this I've got x over y, so that's cotangent, right? And then I have r over y, so that's cosecant. So coming back here, this is cotangent, this is cosecant. So the identity is 1 plus cotangent squared equals cosecant squared. So these are actually pretty important. In summary, these are the 3 Pythagorean identities. These come up literally all the time in a trig class, and then they will come up everywhere. It's like hard for me to even emphasize like how important these are. These are going to pop up in all sorts of weird places. Calculus, physics, it just comes up. So they're super important. And another thing that's very important is that you can derive other relationships from these equations. So for instance, if I subtracted cosine, 1 minus cosine squared equals sine squared, or 1 minus sine squared equals cosine squared, so these two, so maybe I'll just go back to the first list. These two can be derived by just subtracting either sine squared or cosine squared, right? So you have to be able to identify these as well. And then just other manipulations I can do, like 1 equals secant squared minus tangent squared, or 1 equals cosecant squared minus cotangent squared. These are so important, like these relationships, in addition to these. I would write these on note cards and drill them because they're so important, and if you don't recognize them right away, you're going to struggle a lot in not just trig but other classes. So that's the list. You can pause if you need to review any of that. And so next let's talk about the quotient identities. So what I'm going to do now, I'm going to take a look at sine of theta divided by cosine of theta, and just using their definitions. Sine of theta is y over r, cosine of theta is x over r. And so if I rewrite that then, just taking this division problem, y over r divided by x over r, well, when I divide, I actually can just multiply by the reciprocal, right, like this. Okay, and so in doing that, I can cancel out my r's like this, and I'm left with y over x. And what is y over x? It is tangent of theta. So that's pretty cool. And from similar reasoning, if I went the opposite direction, if I did cosine on top and sine on bottom, I would get cotangent, almost the same reasoning. And so these are what are known as the quotient identities. Again, these are super duper important for you to know because these come up all the time and they're very, very handy to use. So if you're making note cards, I would add these to this. So there's a few exercises that we can do where we are forced to use some of those properties. So one example would be like find the value of cosine theta and tangent theta given sine of theta is negative square root of 2 over 2 and cosine of theta is greater than 0. Okay, so here's one way you could ask this question, and we're trying to find two other trig functions. So what I can do here is I can use this identity and then I can plug this part in. So if I plug that in, I get negative square root of 2 over 2 squared plus cosine squared theta equals 1. And so now I can just kind of work this out. So if I work this out, so if I work this whole thing out, this becomes 2 over 4. So this will simplify to 1/2. And then I can subtract that from the 1. So I just jumped ahead with some of the algebra here. But what ultimately is, so cosine squared theta is 1 minus 1/2. So you should be able to work out to this point. So of course then cosine squared theta is just equal to 1/2. Okay, so now we have to figure out what is actually cosine. So to figure out what cosine is, you can just take the square root of each side. Now, one thing I want to remind you of, when I take the square root of 1 over 2, so 1/2, when I take the square root of this, so one property that is very easy to forget, when you take that square root, the technical set of answers, you get plus or minus 1 over the square root of 2. And I know that we need to rationalize this, but just one thing at a time here. So you do actually get two answers. Whenever you've got something squared and then you take the square root, you get plus or minus. But which one do you use? Well, you use this little hint here, right? Cosine of theta has to be greater than 0. So I know then that I have to use the positive one. So just a note on that. Okay, and so now that I know which one I want to use, we do have to rationalize this as well. So this becomes then cosine of theta is the square root of 2 over 2. So that is how we can get to one of those, and that was by using one of the identities. Okay, so let's keep going. I've got cosine of theta now is square root of 2 over 2. Now I can use the fact that tangent of theta is sine of theta over cosine of theta because I have, both of these pieces of information, right? And so then I can just kind of set these up. And if I simplify this, these two just cancel each other out, so this just equals -1. So ultimately we have that tangent of theta is going to be equal to -1. Okay, so let me just show you a few other examples. So here's another one. So find sine of theta given that cosine of theta equals 4/5 and theta is in quadrant 4. So once again, we're going to use the Pythagorean identity. And so I can go ahead and plug in my cosine, in this case, just into its spot. And so this one's going to get a little hairier with some of the algebra here, but what I would encourage you to do is just try to see if you can solve for sine. Maybe pause here and see if you can solve, because I'll just show you the answer. Okay, so if I continue on with this, so I have sine squared theta. This is going to be 1. If I simplify this, I get 1 minus 16/25. And so if I continue on with this, so sine squared of theta is going to be 9/25. And so then we have this choice again, right? So when I take the square root, I get plus or minus 3/5. So which one is it? So now this is almost a little harder, because now you have to think about what is the sine of sine, what is the sine of sine in quadrant 4? And it would be negative. This is something that we discussed in one of my other videos where I went through what the signs of all the trig functions are. So I'll drop a link to that in the description if you want to review that. And okay, so now in choosing this based on what I know about quadrant 4, I can say that the answer here will be negative 3/5. And so that's it for that one. Okay, and so for just one last example here, so find all 6 trig functions given that cotangent of theta equals the square root of 3/8, and theta is in quadrant 1. Okay, so the good news about this, in quadrant 1, all the trig functions are positive. So all trig functions, quadrant 1, they're all positive. So first I want to use, I'm going to just use one of the Pythagorean identities. So I'm going to use a different one. 1 plus cotangent squared theta equals cosecant squared theta. There's more than one way to kind of approach this, but this is the way I want to use those identities. So this is the way I'm going to go. And so now I can just plug in that information, right? So I've got square root of 3/8 now in place of the cotangent squared. And so if I work this all out, so I have 1 plus 3/64, and then that comes out to 67/64 equals cosecant squared theta. Okay, so what I would recommend that you do here is try to see if you can finish this and if you can find all 6 trig functions. Math is not a spectator sport. I say that a lot. So this is one of those things, if you feel like you are getting this, the best thing you can do for yourself right now is pause this video and then hit play when you think you've gotten it or when you get stuck. Okay. So anyways, so now I can go ahead and take the square root of this, and I've just gone ahead and written that this is positive square root of 67/8. So I've taken the square root of 67 over the square root of 64. Square root of 64 is just 8. I've just gone ahead and written this out as positive because, like I said, we're in quadrant 1, so we know everything's got to be positive. So let's just note that here. And now I actually can fill in several more of the values of trig functions. I am going to leverage what I know about reciprocal identities. I've talked about this in another video. So I know that I've got cosecant, so that's 1 over sine of theta, and then I've got cotangent, so tangent is 1 over cotangent of theta. So I can play around with this now to help me fill in some more values. So starting with cotangent, so I can find tangent, and I can rewrite this as 8 over the square root of 3, right? So it's just the reciprocal. However, I know that I have to rationalize in this case, right? So if I have to rationalize, I write this as 8 times the square root of 3/3. Okay, and then I can also do sine. Like I said, cosecant and sine, they're reciprocals of one another. So I can write this as 8 times the square root of 67. However, I've got to rationalize, that becomes 8 times the square root of 67/67. Okay, so we're like 4 down. We've got 2 more to go now, right? So we've really got to figure out like secant or cosine, one of those. All right, so now there's lots of different ways that you can handle this. I have just decided to go this direction, but if you did something different, that's totally fine. So I'm going to go ahead and use the other Pythagorean identity. So sine squared theta plus cosine squared theta equals 1. And I'm just going to fill in some of the values that I found. So I'm going to take this one and fill it in. And so once again, I just want to say, like, you know, try to work this out the rest of the way. See if you can get this on your own. This one's a little tricky. And you'll notice that I chose to use the non-rationalized form. I think that's easier to work with mathematically. We have to put our answers in this form, but I think it's just easier mathematically to work with the non-rationalized form. So, okay, let's keep going. So what I'm going to have here then is cosine squared theta can ultimately be simplified to 1 minus 64/67. And so if I keep going with this, I get cosine squared theta is going to be 3/67. And so then I can take the square root of these. And so now I have to also rationalize. So when I rationalize by multiplying by the square root of 67 over the square root of 67, I get the square root of 201/67. So my cosine of theta is going to be the square root of 201/67. And now I can finish this. Secant is just going to be the reciprocal, right? However, now I have to rationalize, and so this is where it gets a little tricky. Okay, so if I rationalize this, I get 67 over the square root of 67 times the square root of 201 over 201, and then 67 goes into the square root of, or 67 goes into 201 3 times, so I can simplify to this. And so that was kind of a lot of work, but those are the 6 trig functions. And this is a really great exercise to really force yourself to understand some of these properties and get creative with them. The thing about trig is that you have to be very creative with using a lot of these properties, and this is a really good exercise to help start that process and help find your creativity. I do have another example video with more examples, so I just went over a couple of key ones. I have more example videos, so I'll drop a link to that in the description if you want to see more. And then if you found this helpful, just consider leaving a like, comment, sharing my channel with a friend, or subscribing. I'm trying to build a channel where it's free math help to everybody, so I like to keep this free for my students so that, if you're a student of mine right now, you've got plenty of resources, but, if in the future you need help, you can always come back and, get other resources that you might find helpful. So I'm trying to just build something and make it free. And so whenever you guys like or comment or any of these things, it helps me keep going and just continue to work on the channel and the website. And so otherwise, that's it for this one, guys. I will talk to you next time.